So in this problem, we need to show that sine of 2 beta is given by this following trig expression whenever tangent of beta is given to us. Let us begin. So we'll start the problem with the value of tangent beta. So here it's given that tangent of beta, so that's equals to tangent of alpha added to tangent of gamma whole divided by 1 plus the product tangent of alpha times tangent of gamma. Now what we'll do, we'll convert each of the tangent function to its equivalent ratio of sine over cosine. That will be a tangent function. So tangent of alpha will be sine alpha over cosine alpha. This will be added to tangent gamma. So that will be sine gamma divided by cosine gamma whole divided by 1 plus tangent of alpha, so that's sine alpha over cosine of alpha multiplied to sine gamma over cosine of gamma. So let's do one thing. Let's multiply both numerator and the denominator with cosine alpha times cosine gamma. So our numerator will become sine alpha multiplied to cosine gamma added to cosine alpha times sine gamma whole divided by, we have cosine of alpha times cosine of gamma plus sine of alpha times sine of gamma. Fine. Sine alpha times cosine gamma added to cosine alpha times sine gamma. That's a standard formula. That is the formula for sine of alpha plus gamma divided by, then in the denominator, cosine alpha times cosine gamma added to sine alpha times sine gamma. So this is the expansion of cosine alpha minus gamma. This is the expression of tangent of beta. The tangent of beta was given to us. We have simplified this to get sine of alpha plus gamma divided by cosine of alpha minus gamma. So we will keep this aside. Now, coming to the left hand side of the problem, we'll start with sine of 2 beta. Here, now we have left hand side, we have sine of 2 times beta. Now sine 2 beta can be also expressed in terms of its tangent equivalent. That's because, let's say, if we have sine of the angle A, 2A. So that's given by 2 times tangent of angle A divided by 1 plus tangent squared A. So this is how we can express sine of 2A in terms of the tangent function, which means that sine of 2 beta can be expressed as 2 times tangent of angle beta divided by 1 plus tangent squared beta. Now that we already have the value of tangent beta as updated in number 1, so let's replace this tangent beta with sine of alpha plus gamma divided by cosine of alpha minus gamma whole divided by 1 plus tangent squared beta, so that will become sine squared alpha plus gamma divided by cosine squared alpha minus gamma. Now we can simplify this by multiplying both numerator and the denominator with cosine squared alpha minus gamma. We can multiply the entire denominator with cosine squared alpha minus gamma. Fine. So let's further simplify. We will be getting in the numerator, we have 2 times sine alpha plus gamma multiplied to, so one of the cosine gets factored out from the to leave us with cosine of alpha minus gamma whole divided by, so cosine squared alpha minus gamma gets multiplied with 1 to give us cosine squared alpha minus gamma added to, so cosine squared alpha minus gamma, when it gets multiplied to sine squared alpha plus gamma over cosine squared alpha minus gamma, so the cosine squared alpha minus gamma gets factored out, and that leaves us with only sine squared alpha plus gamma. So now we will try to simplify each of the numerator and the denominator. Let's start with the numerator portion. Now what we have in the numerator is 2 times sine of angle A multiplied to cosine of angle B. Now, whenever we have 2 times sine of angle A times cosine of angle B, that's actually equivalent to sine of angle A plus B added to sine of angle A minus B. Now, in our case, A is equivalent to alpha plus gamma and B is alpha minus gamma. That means our numerator is going to become sine of, let's take alpha plus gamma added to alpha minus gamma plus sine of the angle alpha plus gamma minus alpha plus gamma whole divided by, we have cosine squared alpha minus gamma added to sine squared alpha plus gamma. Now, when we simplify the numerator part, this gamma and gamma gets factored out, and we have alpha and alpha factoring out. So we have in the numerator sine of 2 alpha added to sine of 2 gamma. Fine. Divided by cosine squared alpha minus gamma added to sine squared alpha plus gamma. Now, what we'll do, now that the numerator portion is simplified, we'll come to the denominator part. Let's do one thing. Let's multiply the entire numerator with 2. And we're also going to multiply the entire denominator with 2. It thus gives us 2 times cosine squared alpha minus gamma added to 2 times sine squared alpha plus gamma. Right. So we have 2 times sine of 2 alpha added to sine of 2 gamma whole divided by, the reason why we multiplied by 2, because now we have 2 times cosine square some angle. We know that if we have 2 times cosine squared theta, that's actually equivalent to 1 plus cosine 2 theta. And when we have 2 times sine squared theta, so that's equivalent to 1 minus cosine of 2 theta, which means we can rewrite 2 times cosine squared alpha minus gamma as 1 added to cosine of 2 times alpha minus gamma. So we will get 2 alpha minus 2 gamma. And the second term, 2 times sine squared alpha plus gamma, is going to become 1 minus cosine of 2 alpha plus 2 gamma. Fine. So this will become equals to 2 times sine of angle 2 alpha added to sine of angle 2 gamma divided by, now we have 1 added to 1, so that becomes 2. We have 2 plus cosine of 2 alpha minus 2 gamma added to, no, it will be subtracted. From it we are subtracting cosine of 2 alpha plus 2 gamma. Now, in the next step, what we'll do, we'll take cosine of 2 alpha minus 2 gamma and subtract cosine of 2 alpha plus 2 gamma by applying the formula. So let's say if we have cosine of angle A minus cosine of angle B, so here A will be 2 alpha minus 2 gamma and B will be 2 alpha plus 2 gamma. That should give us 2 times sine of the angle A plus B over 2 multiplied to sine of the angle B minus A over 2, which means that now we have in the numerator, so that's 2 times sine of 2 alpha added to sine of 2 gamma divided by 2 plus 2 times sine of angle, now we need A plus B, so 2 alpha minus 2 gamma, let's write it down, 2 alpha minus 2 gamma added to 2 alpha plus 2 gamma whole divided by 2 multiplied to sine of angle, we need B minus A. So we will do, we'll take 2 alpha plus 2 gamma, 2 alpha plus 2 gamma, and from it we're going to subtract 2 alpha minus 2 gamma. So that gives us negative 2 alpha plus 2 gamma whole divided by 2. Right. So we now have 2 times sine 2 alpha added to sine 2 gamma whole divided by 2 plus 2 times sine of the angle. So here we have negative 2 gamma and positive 2 gamma cancelling out. So 2 alpha added to 2 alpha, that's 4 alpha. 4 alpha divided by 2 will be 2 alpha multiplied to sine of the angle. So here 2 alpha and negative 2 alpha cancels out. So we are left with 4 gamma. So 4 gamma over 2 will be 2 gamma. Now we have 2 as a common factor we can take from the denominator. We have 2 times sine 2 alpha added to sine 2 gamma divided by 2. So this will be taken as a common factor, added to 1 plus sine 2 alpha times sine 2 gamma. So we can factor out the 2, and finally this is going to be the value of sine 2 beta, which we needed to show. So sine 2 beta becomes equivalent to sine 2 alpha plus sine 2 gamma divided by 1 plus the product sine 2 alpha times sine 2 gamma, provided whenever the value of tangent beta is given to us, that's tangent of alpha plus tangent of gamma divided by 1 plus the product of tangent alpha times tangent gamma. So this we have showed, hence proved.